Okay, we're going to start section 4.5 today. We've been working through this chapter focusing on different ways to solve quadratic equations. You can see in the box here at the top of the notes page, I'm starting to compile a list of all of the different techniques that we've discussed for how to solve quadratic equations. We're going to add a fourth technique to our list here called completing the square. We've discussed the graphing method. That's when we find the x-intercepts of the parabola using our calculator. We have discussed the factoring method. We also recently have discussed the square root property. That is when you isolate whatever is squared, and then you take the square root of both sides. And finally, we're going to be looking at completing the square here today. Now, this by far is the most complicated method of all the methods that we will be learning here for how to solve quadratic equations. But you're going to notice an element of completing the square is going to have this square root property feel, where there's something going to be squared in our equation, and we will then need to take the square root of both sides to remove that exponent. Okay, so I want to just start out here with example number 1, which I realize the directions here are asking us to actually use that square root property, because I want you to look at the equation and I want you to ask yourself here, what is the thing that actually is being squared in this first example? Okay, you'll notice the exponent of a 2 is actually on the quantity. So what is being squared is the quantity x plus 3. We would need to take the square root of that in order to remove the exponent and only leave behind x plus 3. Okay, the square root of 36, we don't want to just write 6 down when we're working with equations and we're doing something to both sides, particularly the square root. This is when you put a plus or minus in front of the 6, because we know technically the square root of 36 could be a positive 6 or a negative 6. Okay, now what you're going to do next, because the goal here is to solve the equation for x, you're now going to subtract 3 from both sides. Okay, so I like to put that in front of the plus or minus. Okay, and then you're going to go through this problem twice. This is what's going to give you your 2 answers. You're going to take a negative 3 and you're going to add 6, and that'll give you an answer of 3. And then you're going to take a negative 3 and you're going to subtract 6 from it, and that gives you your second answer of negative 9. Okay, so if we were to graph this parabola would cross the x-axis at positive 3 and again at negative 9. That takes us all the way back to the graphing method for solving quadratic equations. Okay, now the key with this, and again this is just the square root property, is making sure that before you're taking the square root of both sides that you have gotten isolated all by itself whatever's squared. Okay, I want you to look at example C and be very careful. Notice what's being squared is the quantity x minus 5. This 2 that is sitting in front, that has nothing to do with the exponent that's there. So before I jump the gun and take the square root of both sides, I need to remove that 2 that's in front. Okay, and now I've isolated what's being squared. So now I would take the square root of both sides. That would mean on the left side I would have x minus 5. And here's an example of a problem that the number that's on the right side, this 27, it's not a perfect square. So I am not going to type it into the calculator. I don't want to be writing down decimals that I have to round. If it's not a perfect square, I'm going to leave the square root symbol over top of the 27 and just put a plus or minus in front there. Okay, and then to wrap this up, you would then move the 5 to the other side. Now this answer is going to have a slightly different look to it than the previous 2 problems here that I have on your paper, and that's because this is as far as you can go. If you were to type into your calculator 5 plus the square root of 27, your answer would forever be stuck as a big long decimal, and you would be forced to round that answer to whatever, 2 decimal places. Okay, we're trying to leave our answers here in their exact form. We don't want to round, so if our number underneath our radical symbol is not a perfect square, then we will be leaving that with a radical sign above it, and here are our 2 answers, 5 plus the square root of 27 and 5 minus the square root of 27. Okay, so let's just build on that idea a little bit more here, looking at example 2. Okay, example 2 is asking us to solve, again, they want us to use the square root property, but these don't look quite like the examples that we just did up above. It's asking us to first factor the left side. Okay? Now remember when we did the factoring technique, we would look at, and this is not move everything to one side, put it in descending order, it's just saying only factor the left side. So that 20 that's on the right, just leave that where it's at. Look at this left side and categorize, okay, what kind of factoring problem is that? Well, it looks like a trinomial where the lead coefficient is a 1, so I can do 2 sets of parentheses and x at the beginning of each. I'm going to make one of these little x charts here. A times c is 16, b is 8. I need 2 numbers that multiply to be 16 but add to be 8. Those 2 numbers are positive 4 and positive 4. Okay. Now, when I get to this point, I notice, hey, these 2 quantities are exactly the same. They're duplicated. So another way for me to write that is just to write the x plus 4 once and then put an exponent of a 2 right here. Okay. Now, if you look at this problem, it really looks similar to these opening problems here that we were looking at, where if we're going to use the square root property, we would then take the square root of both sides. 20 is not a perfect square, so I'm not going to remove the square root symbol from it. And then when I move the 4 to the other side, I'm just going to put it in front of the plus or minus symbol. This is as far as I can go. Okay, let's try another one like that here. Okay, we're just going to leave the 32 on the right side. This also is a trinomial with a lead coefficient of 1. A times c is 9. B is negative 6. The 2 numbers that work for this are negative 3 and negative 3. I fill those in here and then I say, hey, these are the same factor. It's a duplicate. So I'm going to write this as x minus 3 quantity squared equals 32 and then finish off with the square root property. Okay, again, this is not a perfect square, so I'm going to leave the square root symbol over top of the 32. Then pull the 3 to the other side. That will be my answer. Now you should have noticed something that was similar in these 2 problems, and it was this step right here, where when we factored that trinomial, it factored into a repeated factor that was a binomial squared. There is a special name for those kinds of trinomials. Those are called perfect square trinomials. Okay, a perfect square trinomial is when you factor it, it has a pattern where it has a duplicate binomial. Okay, binomial squared. Okay, so here's what we want to do with example 3. We want to pretend that we don't know what this third term is in our trinomial. And we're going to make up what it is, but we want to put the number in there that would make this trinomial a perfect square trinomial. So whatever number lands in this spot, if we were to factor the trinomial, it would factor into like a duplicate factor like we got up here. Okay, now there is a pattern to this. We'll talk about this in a second. Okay, here's what the pattern is. If you actually have a perfect square trinomial, the C value, which is what we're missing in these problems at the bottom, the C value is actually the B value divided by 2 and then squared. Okay? If the B value cut in half and squared is your C value, then this should factor into an identical factor squared. Okay? Let's try that and see if this works, okay? The B value on this problem is a 16. If I were to take that 16, that B value, and divide it by 2, that would give me 8. And then if I took that B divided by 2 value of 8 and I squared it, that would give me a 64. So according to this, if the C value was a 64 and I proceeded with trying to factor this, when I make my X puzzle two numbers that multiply to be A times C, but add to be the B value. So they got to multiply to be 64, but they have to add to be 16. Look at what those two values are, 8 and 8. So this would factor into x plus 8 squared. Okay, now here's the trick. It's always going to factor this, this number right here. That is always b divided by 2, okay, which is what this is saying right here. That's how it looks factored. Okay, so I'm just going to make a little note here how all perfect square trinomials look when factored. And eventually, what you're just going to want to memorize is they will always factor into x plus b divided by 2, that quantity squared. Okay, let's try another one here. Okay, we're missing a c value. Now, according to this, the c value should be the b value divided by 2 and then squared. Okay, you're going to want to get into the habit of always writing down these three values along the side of your paper. Okay, we are working our way to the completing the square process. This is going to make that easier. So for this, the b value is negative 14. That value divided by 2 would be negative 7, and then negative 7 squared would be 49. Okay, please take note that this last value, when you square this middle value, this should always be a positive every single time. Whether you square a negative or you square a positive, this is always going to be a positive. Okay, this 49 is what our new c value should be. And then if we were to proceed with actually factoring this, this should be a perfect square trinomial. A times c is 49, b is negative 14. My two numbers that would work are both the same, x minus 7 and x minus 7. So this factors into x minus 7 squared. And just to confirm this little pattern right here, okay, this should be, and it is, the b divided by 2 value. Okay, so let's pull all of this together on the next page where we can talk through an actual problem from start to finish on the completing the square process. Okay, when you are asked to complete the square, what you're actually doing is you are manipulating one side of your quadratic equation so that it becomes a perfect square trinomial. Remember the problem that we just did? We were kind of filling in what we thought this should be to complete this, to make this a perfect square trinomial. That's kind of the idea here, okay? So I'm going to highlight, this is the part that's super important, okay? This is how all perfect square trinomials look when they're factored. Okay, you'll notice in the box off to the right, I've got the steps for you. I encourage you, especially on tonight's assignment, to reference these steps in this box. This will guide you through how to do this until you kind of have this committed to memory. Okay? Now, this particular problem, and do not assume that problems are going to always be perfect square trinomials. They're not. We know when we factor, we don't always get a duplicate factor squared. So every trinomial is not a perfect square trinomial. So what we're going to do is we're going to assume that the c value that we're given here, that's not what the c value should be if we wanted this to be a perfect square trinomial. So you'll notice over here in step 1, it tells you the first thing you're going to do is you're going to take the existing c value in your problem, you're going to move that to the other side of the equation. Now you notice when I wrote this down, I left a gap between the 16x and the equal sign after I moved the 9 over. Okay, now there's a reason I did that, and we'll talk about that in just a second. Step 2 says make sure the a value, that would be your lead coefficient, the number in front of the x squared, that has to be a 1. Okay, it mentions here if the a is not a 1, you have to force it to be a 1 by factoring it out. We're going to address that on the next video and the next notes page. All of these problems today and on tonight's assignment, your lead coefficient will be a 1, so you won't have to worry about doing anything for that. Okay, now, here's what we want to do. I always like to fill in a little blank here that leaves me a spot for me to fill in a new C value that would make this a perfect square trinomial. Now we know in math that with equations, if you're going to insert a number on one side of the equation, then you have to insert that exact same number on the other side of the equation to keep things balanced. Now remember on the previous problem when we were trying to fill in what we thought the C value should be to make this a perfect square trinomial, what we wrote down off to the side, and you'll notice this with the steps, it says record the B value, B divided by 2, and B divided by 2 squared. So I'm going to write down that the B is a 16, B divided by 2, that would be 8, and then B divided by 2 squared, that would be 64. B divided by 2 squared is what I should add for my new C value. And whatever I'm putting on that side, I need to keep things balanced. I need to put that on the other side as well. Okay? You'll notice that's what it said here. Add the B divided by 2 squared value to each side of the equation. Okay, now it says the left side should be a perfect square trinomial. So it's telling you factor it and then finish by using the square root property, okay? So if we were to factor this left side, okay, we could do it old school, and we could do 2 sets of parentheses. I'll go ahead and do that here for this one, but we're going to end up using this shortcut formula here. But if we were to go old school, we would make an X puzzle. We would think through, okay, what are 2 numbers that are going to multiply to be 64 and add to be 16? Of course, we would say 8 and 8. I'm going to go ahead on the right side and add 9 and 64 together to make 73. And then this is a duplicate factor, so I'm going to write it X plus 8 quantity squared. Okay, now we want to get to the point though where we can bypass this X puzzle and we can jump right to this. Why we want to memorize this. Look at what the B divided by 2 value was over here. Aha! The B divided by 2 value was the 8. So we could have skipped this step right here in the middle, skipped writing this X puzzle, and just said, I can grab this middle B divided by 2 value, put it right in here. Let's say that's my duplicate factor with my exponent out here. And then we can pick up, it says here, finish by using the square root property. Okay, so I'm going to take the square root of both sides. 73 is not a perfect square, so I'm going to leave the square root symbol over top of the 73, put a plus or minus in front of the 73, and then you're going to bring the 8 to the other side, and this is as far as we can go. If you try to type this into the calculator, because 73 is not a perfect square, you're going to be stuck rounding your answer, and we do not want to write our answers rounded. We want to keep the exact answer intact, okay? Okay, we are going to try one more of these here. You can see I did fill out another example here for you to look at and kind of follow through. Let's go ahead and try, we're going to do example B, okay, because this one can be a little bit tricky here, okay? So our first step, I'm going to go ahead and make this so you can see the box up above, okay? First step is to take the existing C value, go ahead and just pull that over to the other side of the equation and create a space for us to create a brand new C value that will make the left side a perfect square trinomial. Step 2, we're already good there. The A value is a 1, so we don't have to worry about that. Step 3, and I want to see this on your paper, so you need to make sure that you are reporting to me what the B divided by 2, and B divided by 2 squared values are. Okay, now be careful with this. The B value is a 5. I do not want you guys to write any decimals. So when you write B divided by 2, I want you to write it as the fraction 5 divided by 2. Okay? When you square that fraction, you really, honestly, it is so much easier to do this and not touch your calculator. Okay? Just take this number, write it as a fraction divided by 2, and when you square that, just square the numerator, make that a 25, square the denominator, make that a 4. Okay? Keep things as fractions. Okay? It's that last number, the B divided by 2 number, that you're going to fill in as the brand new C value, and sometimes they are fractions. Don't let that scare you. This is fine. This is what that C value has to be in order for this trinomial to factor into a duplicate factor squared. Okay? All right, so now I'm going to use this shortcut right here. I'm not going to, in fact, if I made an X puzzle, I'm just going to draw it right up here real quick. Here's your X puzzle for this. Who wants to take the time to try to think of two numbers that are going to multiply to be the fraction 25/4, but add to be this b value of 5? That is a tricky X puzzle. Thank goodness we have this shortcut right here for how all perfect square trinomials look factored. So I'm going to just jump to that shortcut. I'm going to go ahead and put my parentheses that it's going to be this duplicate factor squared, and I know what goes over here in the parentheses should be whatever I said the b divided by 2 value is off to the side. I said that is the fraction 5/2, so that's what I should fill in there. Okay, as far as the right side, I would encourage you to just pick your calculator up, type 11 plus 25/4, but I do not want you to write down a decimal, so hit the math button, then the fraction key, and it should switch that decimal back into a fraction for you. I believe it's the fraction 69/4. Okay, and now we're finishing off with the square root property. You're going to take the square root of both sides. Okay, that removes the exponent from the left. If, when you're taking the square root of the fraction, if your numerator or denominator is a perfect square, take the square root of that number. If the other one's not a perfect square, then leave the square root symbol over top of that. So in this case, 69 is not a perfect square, so I'm going to leave the square root symbol over top of it. But I can take the square root of 4 and make that a 2. Now, you don't need to put a plus or minus in front of the square root of 69 and a plus or minus in front of the 2. Just one plus or minus will do it for the whole fraction. And then to finish this off, you're going to subtract the fraction 5/2, and this would be how you would write your final answer. Okay? All right, again, you can see on your notes page here, I guess I did report